Hey guys, so this is the approximation of pi code. Obviously, right here is the formula. We have to learn how to put that in or figure out how to put that into an algorithm. The 4 is constant. We don't have to worry about that. It's inside the parentheses we have to concern ourselves with. There's two key things going on. One, these are all fractions. Okay, even the 1 itself could be expressed as 1 over 1. The denominator is going up by 2's every time. So that's one thing. The other thing we have to concern ourselves with is we are alternating between pluses and minuses every time, all the way down to infinity. So those are what we've got to deal with. We also have to do this inside a method because that's what chapter we're on. And so we're going to have to use method calls and headers. Okay, so let's go ahead and get started. Got my skeleton set up, nothing crazy going on here. I do need a scanner. So that my user can input how many iterations of that fraction chain we want to use. Okay, and that's pretty much all we need up here in main. And then, let's see, did it give the header? Method should return the value of the calculation. Okay, so we are going to come back up here and print we'll just call it ApproximatePi, and then we'll send it none. Okay, that's erroring right now because I haven't written the method. Okay, so I've got my question, I've got my prompt, here's my method call. It will return a double, including there. Okay, outside of the main method, let's go ahead and get the header. Public static double ApproximatePi. I need some kind of value in here, so let's call it iter for iterations. And then down here at the bottom, actually, -1. So I'll fix that at the end, but that way I'd lose the error. There we go. All right, so got my number of iterations, so I need to make that loop. Okay, starting at 0, less than iterations, that'll go every time. Okay. Let's see. Just to save some complexity, let's make our denominator a spare variable. Okay, I think that'll work. All right. Okay, so remember we got two different versions of things going on. So if I mod 2 double equals 0, so these are even iters, okay, which thereby means this is the odd. Okay, if that happens, oh, I also need a total. Double total 0. Okay, since I'm starting at 0 and that's a positive 1, that's where my pluses are going to be. All right, so the fraction is 1 over whatever my denominator is. Okay, because I don't need these, it's just one line, which also means this. Okay, so for odd values, I subtract. Now, this is not finished yet, but we'll get with that in just a second. Ready to return. What I want to do is I want to do 4 times whatever my total ends up as. Okay, So basically that's what's going on. We're not finished, but I want to show you what happens. Okay, how many iterations? We'll go 10. Okay, we got 0. We do 1,000,000. Pi is still 0. We've got some issues going on. Okay, issues basically end right here. So we've got 1, which is an integer, and denominator, which is an integer. Integers divided by an integer are still integers. So the first time this goes through, this is going to equal 1. But then every time after that, oh, wait, I forgot that. That's why it kept being 0. Denom plus equal 2. There you go. I forgot. Every value, no matter if it's add or subtract, goes up by 2. So, let's try this again. 10, 4, that's what I was expecting. And 10 million is still 4. Issue is because of that integer error. Integer divided by an integer is still an integer. We need doubles. So what we have to do is we have to make sure one of these values in each case is a double. Does not matter which one, you could change your variable. I'm going to change the ones just so I can see what happens. This will unlock all the decimal values we need, okay? So now if we do those values, the larger the number, the closer we get to pi. 3.0418396, okay, not bad, but that's only 10. We go up to 10 million. 3.1415925. So we're still not there, but we're getting a lot closer than we were. And that's approximate pi. Have a great one.